Hello everyone, this is Astronomy. We're going to be looking at the hypotheses, the theories there are about the formation of the moon. I'm Chris Troha. So this is a great activity that I usually do in the classroom where groups end up doing some research on the different theories and then have a discussion and try and figure out what the best one is. So I'm going to talk about this a little bit, and one thing that's really important in science is that we use the evidence that's available to us to try and figure out what the best possible scenario is, or best possible explanation is. So here's the evidence that we have when it comes to the moon. The Earth has an iron core, but moon rocks do not have iron, the ones on the surface. The Earth's average density is 5.5 grams per cubic centimeter. The moon's average density is 3.3 grams per cubic centimeter. So we have some definite differences here. The Earth has a very specific isotope of oxygen. Interestingly, the moon also has that same unique isotope of oxygen. Remember, an isotope is it's oxygen that has a certain number of neutrons or a certain atomic mass. And strangely, the Earth, compared to the size of the Earth, the moon is much, much bigger than other moons and other planets compared to those planet size. So here are the different hypotheses that we have. Number one is the accretion hypothesis. Now, what is accretion? Accretion is where we have little particles accumulate into bigger particles. So this is one where the moon is a little world that formed in orbit around the Earth at the same time the Earth was formed. So there's a bunch of stuff out there, cosmic dust, and it started forming together, and they just eventually formed into two different bodies, one being the Earth and one being the moon. So here's some things that are pros there. We do know there's a lot of material. It could definitely clump together. It could accrete and to form this. So it's possible. Now, on the other hand, if that was the case, why does the Earth have iron but the moon doesn't? And if this was a possibility, why don't some of the other planets our size also have moons? So let's look at hypothesis number 2, the moon capture hypothesis. The moon was just somewhere out in space, and it came by and got caught up in the Earth's gravity and now is in orbit around the Earth. So this would really explain why the moon doesn't have iron, because it came from somewhere else. But that oxygen isotope that's the same, that would be really strange for it to also have that. And the physics behind this big object flying in and being captured by the Earth's gravity, it would have to be going at exactly the right speed, at exactly the right distance, and for that to happen. That would be very tricky and highly unlikely. Number 3, we have the fission hypothesis. Fission is when we have one large object and separates into two. So this is one where the Earth was spinning faster than it is now, and the Earth spun so fast that this object just clumped off of the Earth. You can imagine if you had a big lump of clay and you spun it around in a circle, then some of that could just fling off a little bit. So this does explain why the moon doesn't have any iron, because if it came from that outer part of the Earth's mantle doesn't have as much iron as further down, and it would have a similar density to the Earth's outer layers. The cons on this, the energy of the system doesn't add up. The Earth would have to be spinning way too fast. Now, it is interesting that the Earth is slowing down over time because of the tidal pull between the moon and the Earth. But if they look back in time, it would have been spinning much, much faster than was possible. The moon would also probably be orbiting the Earth's equator if it came off at that point, because that's the spot that would be shifted, and that's what it would pop off from. Rock's density is similar, but composition of not. These are so a lot of cons here. And if this was the case, other planets probably would have been spinning around fast and had moons like that as well. Number 4, a giant impact hypothesis. This is one where a very large object crashes into the Earth while it's still in forming, and debris and things come off of the Earth and from that impact and make the moon. So pros, there's definitely a possibility of collision. There's lots of collisions if you look at the moon, and even evidence on Earth that we have collisions from large objects. It does explain the lack of iron on the moon, or lack of iron core on the moon, because if most of the material coming off was from the outside of the Earth, then there wouldn't be a lot of iron there. It does explain why there's that same isotope of oxygen, because again, it's coming from material from the Earth. It's creating that. And the physics is also possible, showing that that's possible. Also, kind of an interesting thing, would explain why the Earth is tilted on its axis if it was hit at that angle. So what's the con? Well, even though physics shows that it could collide and that could happen, there's one other issue. It's called the Roche limit problem, and it is kind of a complicated thing. I'll talk about it real quickly, but it says that the moon probably might have broken up if we went with this method. So what is that? It's this idea that when the Roche limit is this white line here, when the object is beyond that, it stays as one object. But as it gets to it, the tidal pulls, the pulling of the Earth itself as it spins around would be greater than the gravity holding the object together, and it would break apart. So this is what happens when you have Saturn's rings and things like that. Is these objects, instead of forming into a moon, they stayed as little particles. All right. So what do you think happened? I don't know. You'll have to check. There's a couple videos that I've posted that will give you some ideas of what scientists think, but see which one fits with what you think. All right. Have a good day.